Hello, everybody. Welcome back to Free Calculus with Mr. Beck, where I've got your back and you've got your back. We're here today to talk a little bit about area of triangles. You guys should be pretty familiar with area of just any right triangle where you have 1/2 base times the height. What we're going to do is we're going to build off that to work on different types of triangles. What happens if we don't have a right triangle? Specifically, we're going to work on side angle side triangles and side 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 triangles. Now, we could find areas of really any of the different types of triangles that we come up with. Side angle, side angle, side angle, 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 side. What we really have to do is just solve the triangle to find the area, or to put it in terms of a side angle side. So that way we're able to come up with just a simple area formula. What I'm going to do is I'm going to derive the side angle side formula for you. So what I'm going to start with is I'm going to draw just any random triangle. I'm going to put A right here, B right here, and C right here. And we're going to make this the height of our triangle. That way we end up with a form of a right triangle. And we have the side length B right here, which is going to represent the base of the triangle. So as you guys are familiar with, your area of this triangle is going to be 1/2 base times height. Now, what I'm going to do is I'm going to manipulate and rearrange a few things. That way you can see where the side angle side area formula comes from. So I'm going to begin with something that we did back in 8.2, where we said the sine of angle A is going to equal H over C. And then we will rewrite this. So H is going to equal C times sine of A. So what we could do is we could rewrite our area formula. If we take this H, C sine A, we substitute it in right there. We get our area of our triangle is 1/2 base times C sine A. So pretty simple way that we just derived that formula right there. So straightforward. Area is 1/2 BC sine A. Now, what do I care about? What's most important to me? So if I have side C, which is over here, and I have my side B, let me go ahead and highlight these for you. So if I have my side C and my side B, what I also have is my angle A. That's why we have the side angle side triangle. Now we could do something similar. Rather than say sine of angle A is H over C, if we said sine of angle C is H over A, let's put A right there. Sine of angle C equals H over A, and that leads us to say that H equals A sine C. So now our area formula would be 1/2 B times A sine C, or 1/2, we'd like to write it alphabetically, AB sine C, which is this first area formula right there. And if we wanted to, we could do the same kind of mentality, drop an altitude that, I didn't make this right triangle, but if we drop the right triangle there, we can come up with our third area formula. So what do we care about? Once again, if we have the side angle side triangle, our area is going to be 1/2 two side lengths that we know multiplied times the sine of the angle in between. This is really just that area is 1/2 base times height, but it's rewritten in form that we don't really need our height. Go ahead and actually put that into application. I have problem number 1 here, where I have a triangle FSH. So let me go ahead and try to draw this out. So side F, I'm going to put right here as 4. Side S, let's make that a little bit longer. Side S, so that's angle F, that's side F. Angle S, let's go ahead and put angle S right there. And so side S is right here. Let's write that side S right here, and it has a side length of 6. And angle H is going to be the angle in between, which is 50 degrees. So what does that tell me? This is our side angle side triangle. So our area formula is going to be 1/2 two sides multiplied that we know. and then times the sine of that 50 degrees. Let's go ahead, throw that into the calculator. We have 1/2 times 4 times 6. Probably could have done this one in my head, but that's okay. Times the sine, go to our trig, sine of 50 degrees. And this shows, unintentionally shows that, I don't know if you remember back in 8.1 and in chapter 7 where we talked about the cosine was actually the complementary sign. Not quite sure why the calculator is putting it in these terms. Always an interesting thing. Throw the decimal down and we get our 9.193, and this would be units squared. All right, so on to problem number 2. In order for us to do problem number 2, we have to talk about the area of a side-side-side triangle. Now, area of a side-side-side triangle, this proof is not quite as straightforward. And if we were in our typical classroom, I would actually walk through it, where what's kind of nice about this is it brings back some of the stuff from chapter 7, where it leads into the cosine of, I'm going to go ahead and call this angle C over 2. The half angle formula is 1 plus cosine of angle C over 2. And square root of that, of course. If you remember, that's plus or minus. So what that would give us is cosine squared of C over 2 is 1 plus cosine of C over 2. As I said, if this were a typical classroom, we would take this and we would rewrite it in such a way that we would get our cosine of that angle, we would get our sine of that angle, and eventually it's going to lead us to this formula. If you're curious, there is a proof on this. This is page 545 in our book. So I strongly encourage you to take a look at that just so you can get that frame of reference. I feel like some of that proof is going to be lost if I start bringing all these random things up here through the video. So I'm going to go ahead and say, where do I feel like this is important? Let's talk about this area formula, area, which our book tends to use the variable k for area. That area is going to be the square root of s, where s is going to be, you see right here, s is that, s minus a, s minus b, s minus c. Written a little poorly, I'm sorry. So our area formula is going to be that. Now, what does s actually represent? I said, okay, this is s. What s represents is half the perimeter. So if I know half the perimeter, then I can put this into our area formula. I don't feel like I'm doing this justice because I really like to see that proof. I like to go through that proof. Let's just go ahead and put it into application right now, though. So as with anytime I have a formula and I want to use the formula, in order for me to kind of train it to memory, I have to rewrite it. So our area, which I'm going to call K, just like our book does, is going to be, square root of S times S minus A times S minus B times S minus C. Now, what does S represent for our problem here? This is 1/2 our perimeter, which is 4 plus 3 plus 6. 4 plus 3 is 7. 7 plus 6 is 13. Half of 13. I'm just going to go ahead and leave that as 13 halves. So our area of this triangle is going to be the square root of 13 halves times 13 halves minus 4 times 13 halves minus 3, and then times 13 halves minus 6. So that would be the square root of 13 halves times 13 halves minus 4, that's 13 halves minus 8 halves, which is 5 halves. 13 halves minus 3, that's 13 halves minus 6 halves, or 7 halves. And then 13 halves minus 6, that's 13 halves minus 12 halves, which is 1/2. Now, as much as I'd like to say I can do this in my head, I can't. So what I'm going to do is I'm going to multiply my numerators together, 13 times 5 times 7, then times 1. gives me 455. So this is the square root of 455 over 2 times 2 times 2 times 2, which is 16. We divide that by 16. We are going to get that fraction. I know, shocking. Let's go ahead and throw the decimal on there so we can get 28.4375. 4375. Now, that is actually the square root of that. So let's go ahead and get the square root of that. So squared. Try that one more time. Square root of that answer that we just had. And 5.333. That would be 5.333 units squared. So once again, what we did was we found half the perimeter, and then we took the square root of half that perimeter and times half the perimeter, subtracting each of the different side lengths. Now, as I said, I mean, this is really a specific formula. This is actually called Heron's formula. I don't think I wrote it up there. This is called Heron's formula or Hero's formula, Hero or Heron's formula. He was an ancient Greek. Where I feel like this formula actually gets used and used in its entirety, as we go forward from here, I typically don't use the formula in this form. I use what I have written up here as the area of the equilateral triangle. The area of the equilateral triangle is really a form of Heron's formula. What I'm going to do is I'm going to say with an equilateral triangle, let's call that side length L. And so if we take our perimeter and divide it by 2, that would be 3L divided by 2. So if we applied Heron's formula, our area is going to be the square root of 3L over 2 times 3L over 2 minus one side length, which would be L. And we do that actually 3 times total, so I'm going to cheat and just call that cubed. So that would be the square root of 3L over 2 times, would be 2L over 2. So that would be times L over 2, that quantity cubed, or square root of 3L to the 4th over 2 times 2 cubed, which is 16, kind of similar to what we had down here. And we could say the square root of L to the 4th is L squared. L squared, we still have the square root of 3. And then the square root of 16, if we take that denominator, would be over 4. Now, more specifically, rather than call this side length L, if we call it S, the reason why I didn't use S before was I didn't want to confuse it with the perimeter. That's where we get the square root of 3 over 4 times the side squared. So let's actually do a couple more pieces of practice. With this, I'm assuming this is going to be a side angle side triangle because that's what we have here. Let's go ahead and actually confirm what I believe is going to be true. So if I call this side length 4, this side length 1, not drawn to scale, so not to scale. So that would be opposite angle B. That would be opposite angle C. Angle A ends up being 120 degrees. And yes, this is my side angle side triangle. So my area, which again I'm just going to call K, is going to be 1/2 times 4 times 1 times the sine of 120 degrees. Now, do we know what the sine of 120 degrees is? Yes, we do. That would be the square root of 3 over 2. So this is going to be 2 times the square root of 3 over 2, or just the square root of 3. Now, square root of 3, let's go ahead and type that in the calculator, because since we're dealing with this as an area, as much as I love the square root of 3 as an answer, having a decimal is going to be a little bit more important. 1.732, and that would be units squared. And then 436, if you look, example number 4 is just the same as example number 2, just different variables. So let's go ahead and say this is 5.333 units squared. don't worry, we're going to be using this formula again. Actually, let's go ahead and change it. So let's call this example 4b. What happens if this is equilateral and the side length is, let's call the side length 8. Then our area is going to be the square root of 3 over 2 times side squared. So that would be square root of 3 over 2 times 64, or 32 square root of 3. And once again, I don't want to leave that just as a decimal, so 32 times, and we just happen to have the square root of 3 up here, so type that in. That's where we get 55.426 units squared. Sorry to change a problem like that, but don't want to use the same problem over and over again. So you see the two area formulas once again. If we have a side angle side triangle, two area formulas, side triangle, we could use Heron's formula. In video number 2, what I'm going to do is I'm going to introduce new terminology, segment of a circle, and then I'm going to go through one of my favorite problems of all time, which is called the cow problem.